Hi everyone, it's Sorkin. Today we have a problem when we are given an input array 1, 2, 3, for example, in this case, and we need to find a next permutation. So what's the next permutation? Next permutation in our case is a permutation that is lexicographically greater than our input. So for example, in this case, we have 1, 2, 3, right? And the next permutation for the 1, 2, 3, the next reshuffling of numbers that will give us number that is greater than 1 to 3 is 1 3 2, right? So let's say that, how about in this case? In this case is 2 3 1, right? The next permutation is 3 1 and the 2. So how about the case when we don't have a permutation that is greater than our input? So for example, 3 2 1. In that case, we need to return the lowest possible order. So in our case, it's going to be 1 2 3. And another important requirement is that our solution must be in place, so we cannot use any extra memory. Otherwise, we could use backtracking, generate all possible permutations and select the next greater one. So but we need to solve our problem in place without using extra memory. So we cannot apply any standard solution for this problem, meaning like any standard algorithm, backtracking or similar, because we need to solve this problem in place without using extra memory. So what we are going to do, let's break it down step by step and see that which steps we can take in order to solve this problem. Let's take first this one, 3 2 1, right? So in this case, what is the next permutation? The next permutation in this case, we cannot have any combination that is greater than 3 2 1, right? So we are just going to reverse this string and return the result. So what it means? How about this case? Let's take one more scenario, 3 1 2, right? So let's say that we have 3 1 2. What is it? Can we have a next permutation in this case? Yes, we can. And in this case, the next permutation is 3 2 and 1. So what it means? It means that we need to find two neighbors, right? So let's write down our first rule. Our first rule is so let's call it array. This is our array, right? And this is our array. So the rule is, the first rule, that our I, right, it should be more than the next element. So for example, in this case, this is I plus, right? So it should be array I plus 1. Okay, this is our first rule. So we are starting from the end of our array. So we'll find a first element that is greater than its neighbor, so its next neighbor, and we are swapping them. So this is the first rule. So this is the very simple example. So in this case, we can apply only by swapping these two neighbors, right? Let's take another example. Let's say we have 3 1 2 3 1 4 3 2 1. So how about in this case? In this case, let's again start with our first assumption, right? So we are going to find the first element that is greater than its neighbor. So we are checking all the way. So here we have the element that is less than its, so I is neighbor that is greater than its neighbor, right? So in this case, it's 4. 4 is more than 1, so it's our array I, right? And this one is I plus. So we find that. So in this case, right, with which element we are going to swap it? So with its neighbor, if we are going to swap it with its neighbor, so we have what? We have 4. So what we have? We have 2 3 4. We have 2 3 4 1 3 2 1. Is it the next greater permutation? Is it the next permutation? No, because we can have 3 2 3 2, right? So it means that this is not the next one. So it means that we need to find a number starting from the end of the array that is greater than our our current element. So the second rule, so we can define our second rule. What's our second rule? Our second rule is we need to find the j, right? We need to find the j. So array j, which is greater than our current element, that the I that we found, right? I that we found here. So greater than, so we find that it is here, right? It's our array, it's our j. Okay, we find that. So more than our array I. So this is the second rule. So now we are swapping these two. Let's swap them. So what we get here? We got here 3, 2, 4, 3, 1, and 1, right? So this is our permutation. Is it the next greater permutation? No, it's not the next greater permutation, because as if we pay attention to this part of this array, right? What is in here? It's the all elements are increasing, right? That's why we got this element, because this is the first one that is decreasing. That is, so all the way down here, all elements are starting from the end of the array, they are increasing. So what it means? It means that we need to reverse all elements that comes after I, right? That comes after I. So we can define our third rule. Our third rule is that the reverse our array starting from I to array size -1, right? So let's apply that logic here. So we are applying that logic here. Let's write down in another number, in another color. So we have here what? We have 2, 3, 2, and we are reversing, right, this part of the array. So we are reversing this part of the array. So what we got here? We have 1, 1, 3, and 4. Okay, is it our next permutation? Yes, it is, because this is the first number after our input that is greater than our input. So this is the 3 rules that we are going to apply to our input array. Okay, let's go over our solution. So first thing that we do here, we are finding our I. So we are moving we are defining I as a nums length -2, because we are going to start with the 2 elements from our end of our array, right? And we are moving our I pointer until we find an element that is less than its neighbor, its right neighbor, right? So until I is more than its right neighbor, we are moving I pointer. Now we have our I here. What we do next? Next, we are checking that if the I is more than or equals to 0, so if it means that there's a positive I, we are going to find our j, right? The next element. What is the j? Again, we are starting from the end of our array, right? And we are trying to find the first I that is greater than our I. So until our j is less than or equal, we are moving our j pointer. Once we exit this loop, we have our int I and we have our nums I and nums j. We have our 2 numbers. So what we are going to do, we are swapping those numbers. So here we have a function for or method for the swapping. We are swapping those values. The next one, what we do? Next one is we swap those elements. Now in our case, right, in our example, so what we do, so the rest of the array, so starting from the I plus 1, so the rest of the array is starting from the end of the array, it's increasing. So right, so we need to reverse that. So we are reversing, starting from the nums I plus 1 to the end of the array, we are reversing that part of the array. And for the reverse part, what we do here, we are reversing, and we are using a swap function to reverse our elements. Okay, that's it for today. And let's before our closing our today's problem, so let's calculate our time and space complexity. What's our time complexity? Time complexity is of n, right? Because we are going over our array only once. And how about the space complexity? Space complexity is we are solving this problem in as it required, right? We need to solve that in place, so we are not using any extra memory. So our space complexity is of 1. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.